You ever stop and think about the invisible chemistry that's happening all around us, all the time? I mean, the reactions that literally shape everything from the air we're breathing right now to the water in our oceans. Well, today, that's what we're diving into the incredible field of environmental chemistry. So, what exactly is environmental chemistry? Honestly, the best way to think about it is like being a detective for the entire planet. These scientists are out there tracking the journey of all sorts of chemicals, not just the pollutants we create, but also all the natural stuff that cycles through our ecosystems. They're trying to piece together this unbelievably complex chemical web that keeps everything running. And that's the big question, isn't it? What happens when that balance gets thrown off? When harmful chemicals, pollutants get into the system, they can really mess with these natural cycles. And we see the effects everywhere, in our atmosphere, in our water, and even in the land itself. So let's start at the top, literally, with the very air that surrounds us. Pollution in the atmosphere is probably the most obvious way we see this chemical balance go haywire, though sometimes the biggest threats are the ones you can't see at all. Air pollutants pretty much fall into two main camps. On one side, you've got your gaseous pollutants. These are the invisible ones, things like oxides of carbon, nitrogen, and sulfur. Then, on the other side, you have particulate pollutants. This is the stuff you can see, like dust, smoke, and fumes. And believe me, both types pack a serious punch. And the impact of these pollutants is, wow, it's pretty staggering. Take those invisible gases, like nitrogen and sulfur oxides. When they mix with water in the atmosphere, they create acid rain. And this isn't some minor thing. We're talking about rain that's strong enough to damage entire forests, make lakes unlivable for fish, and literally eat away at historic stone buildings and statues over time. Now, let's go way, way up into the stratosphere. Up there, we have this amazing chemical shield called the ozone layer. Just think of it like the Earth's very own built-in sunscreen. Its whole job is to protect all of us down here from the sun's most dangerous ultraviolet or UV radiation. But how could something so huge be so fragile? Well, the problem often started with man-made compounds called chlorofluorocarbons. You probably know them as CFCs. When these CFCs float all the way up into the stratosphere, the sun's powerful UV rays act like a sledgehammer, just smashing them apart. This unleashes these super reactive atoms that start this absolutely devastating chain reaction. Get this, a single one of those atoms can destroy thousands and thousands of ozone molecules. It's a perfect and scary example of how a tiny chemical key can unlock a massive environmental disaster. Now, pollutants don't just stay up in the air. Eventually, a lot of them find their way into another resource we absolutely can't live without, our water. And the chemical health of our water is a really, really critical piece of the whole environmental puzzle. So how do chemists actually check on a river's health? It's almost like taking its pulse. And one of the most important vital signs they look for is something called dissolved oxygen, or DO. See, just like we need oxygen from the air to breathe, fish and other aquatic life need oxygen dissolved in the water. It gets in there from the atmosphere and from underwater plants, and it creates this very delicate balance that the whole ecosystem depends on. Okay, but here's where pollution just throws a wrench into the whole system. When organic waste, think sewage or fertilizer runoff, gets into the water, it's like an all-you-can-eat buffet for bacteria. These bacteria go crazy, multiplying and breaking down all that waste. But in the process, they use up massive amounts of that dissolved oxygen, basically starving the waterway of the air it needs to breathe. So it's a direct link. The more pollution you have, the less oxygen there is for everything else. This gives environmental chemists a really simple rule of thumb. All they have to do is measure the dissolved oxygen, and they can get a quick snapshot of how healthy that water is. If the oxygen levels are low, it's a huge red flag that pollution levels are high. It's a simple relationship that tells a really powerful story. All right, so we've gone from the air to the water. The final major piece of this puzzle is the ground right under our feet. Land pollution is a direct threat to our soil, to the food we grow, and to the very foundation of all our land-based ecosystems. And when we look at the major sources, two big ones really stand out. First, you have pesticides, all those chemicals we use on crops that can stick around and build up in the soil for a long time. And second, there's just the massive, ever-growing amount of solid waste we all produce, from the trash in our homes to industrial byproducts. Okay, so we've talked a lot about the problems in the air, the water, and on land. But environmental chemistry isn't just about pointing out what's wrong. It's really about finding the solutions and figuring out how we get to a cleaner future. A huge part of this is just getting a handle on the waste we're already making. And that means attacking it from all sides. Recycling materials so we don't have to make new ones, using advanced sewage treatments to clean water before it goes back into the environment, and finding better ways to manage solid waste, whether that's through controlled incineration or safer landfills. All those management techniques are absolutely crucial, but they're mostly reactive, right? They're about cleaning up the mess after we've already made it. So that brings up a really powerful question. What if we could just stop the pollution from being created in the first place? And that, right there, is the revolutionary idea behind what's called green chemistry. It is a totally proactive approach. Instead of focusing on cleanup, the goal of green chemistry is to invent smarter, cleaner, more efficient chemical processes and products right from the get-go. It's about designing out the pollution before it ever has a chance to exist. And really, the big takeaway here is this fundamental shift in thinking. Green chemistry isn't about being less bad, it's about being fundamentally good from the very start. It challenges us to look at literally everything around us, from the plastic in your phone to the dyes in your clothes, and ask a simple question. How can we make this better? How can we reinvent this? It's really a call to action for a whole new generation of innovators. So, what in your world do you think is just waiting for its green chemistry breakthrough?